Alright, so whenever I start to approach something, I always like to think through what are the steps, what are the things I need to consider, what do I need to keep in mind. And usually I go through this iteration 2 or 3 times in front of myself and just say, okay, step by step, what needs to happen.
You look in a mirror when you do it?
Occasionally. I usually turn my webcam on and I run it in the upper right-hand corner.
That would be smart, though. Actually, you record.
Yeah. I'm going to go back and leave faces for myself. It's fun.
Pause and draw on.
That's right. Do you guys do Google Hangouts?
What's that?
Google Hangouts?
Every week.
Every week?
Yeah.
You never done, you should try, you have like a Gmail account?
Yeah.
Go
like
in.
Google, like a Google.
Yeah, Google Plus account, right, yeah. If you go and do Hangouts, there's these add-in tools for Hangouts, and one of them's called like Gadgets or something, and it does that for you, like it does the face recognition. So you just like on your computer, it's a little like web chat thing, and you just go in and say like add a hat, and it'll put a hat on your head. Or add, like an eyeglass spectacle, and it'll like follow your head and stuff, and everybody you're chatting with can see it, and so.
That's awesome.
Maybe we'll do class that way. We'll do virtual one week, and we'll do it in a hangout. There's a small enough group we could probably fit everybody in the hangout. We won't get anything done, but.
Can you hijack other people's picture and like throw stuff in it that they're not expecting? That would be cool.
I haven't seen that, but I'm not saying it probably couldn't be done. So, yeah, we should do hangouts one week. Then we can do them live, and they'll automatically turn into YouTube videos.
Right.
There you go.
You blast it for everyone to see.
What?
You blast it for everyone to see.
Exactly. All right, so shopping cart. So we start off and we have a list of products, which we already have that part done. And then from there, we want the ability to add item to cart. And then we'll want a shopping cart view, the ability to delete a product from the cart, ability to change quantity of an item in the cart. We'll want to show total for all items in the cart, and then kind of like summary navigation, continue shopping or checkout. Okay. Anything else that I'm missing? That's alright. I know I put a lot of unnecessary in front of there.
Is this bit a chapter? Or this
Chapter. This is like chapter 9. Yeah, we'll start there. If we run across anything, we'll evolve. Alright, so let's go ahead and we'll create a new controller to kind of put all this in there, and we'll call it the shopping cart controller. Maybe I'll just call it the cart controller. Yeah. Alright, so we'll have the cart controller. Let's go back up to our models and kind of kick through this a little bit. So right now we have a product class, so that represents one item. I think for what we have, it should be sufficient enough, cover what we need. I'm going to go ahead and create another abstract for I shopping cart, and then another concrete yeah, we'll just do a class. Oh, let's wait. Alright, so what do we need in our shopping cart? What properties will we need for our shopping cart? And I'm asking you to give me answers. What?
I'm not for item, only the item. Doesn't say price, but there's an item.
Yeah. So we'll need.
Total.
Right. So we'll need the total price of the cart. We'll need IEnumerable product. So that'll be all the products in the cart. As I'm typing that, I'm thinking we probably actually need to have another type, which will be like a cart item. What was that?
Well, it's not a quantity.
Right, exactly. So I'll just make a class instead of making another interface for it. Let's put it here, add class. Shopping cart item. Or here, we'll do order item. Alright, so your shopping cart has an order in it. Each item in there is an order item. Okay. So this will have product, prop, int quantity. Do we think we'll have decimal quantities? Not really. Not really worried about it. Alright. Prop, decimal, item total. That'll probably be more of just a straight get, so it'll be get return product dot price times quantity, and I hate to do this, private int underscore quantity equals 0, get return quantity, set if value is less than, let's just do it this way, quantity equals value less than 0, 0 else value. Is that right? Boom. There we go. So if we go to set the quantity and the quantity is less than 0, treat it as 0, and if it's not less than 0, then do it to whatever the quantity is. Okay. So this will be order item. This will be order items. Anything else at this point? Sure, why not?
Because your subtotal and your total would have a different.
Oh, that's true. So we'll have tax rate, right?
The total and subtotal.
Subtotal, price. So what is this? Oh, this is the interface. So that's a get. Subtotal for order items before tax. Total price of cart after tax, or including tax. Tax rate for cart. Okay. Good enough? Okay, what kind of methods? What kind of, you said I need methods too?
Like add to cart or clear cart.
want to pass in the subtotal?
to get your total.
I'm going to have a total price property.
Right. So how do you set it if you don't know, you need to have your tax rate in there?
So I do need the tax rate, I agree.
Tax rate for, and then the total for your part.
But I've got my order items here. I have a subtotal price
Right.
property for the cart.
So just
So-
use that as a
Yeah.
define that.
Right. And remember, this is an interface, so the implementation will vary. So I'm going to argue that we don't need a method. But I think add is good, remove is good. Alright. So now we need a concrete implementation of this. So this will implement shopping cart. Which lives there. No. So implement. So let's move these down a little bit. Tax rate. Subtotal, total price. Alright, so let's start off with private list of order items. And return order items. Tax rate will be just that. Total price, we'll call compute total. Have a private. The subtotal will return order items I dot item total. Clever. Did I lose you? Okay. So then this will be order items dot add item. And this will be add new order item. Product equals product. Quantity equals 1. Okay. Order items dot remove item. Clear. Return subtotal times quantity 1 plus tax rate. Ooh. Oh man.
I have to actually declare
What?
that.
F6.
Well,
Look at that. Oh, I forgot one. Constructor. Order items equals new list. There we go. Why do I need the constructor, Eli?
Huh?
Why do I need the constructor?
Are you started?
Yeah. Five.
Don't you need to pass it in an interface on the iShopping cart or that?
No, I'm implementing iShopping cart. You can call pass.
Huh?
You can call pass.
Pass.
Who you gonna pass it to? This is a new game I'm making up, by the way. You give it to Adam?
That's to you.
Me? No. I deflect. All right, Brian, go.
Well, you need some kind of base definitions for the items that are actually in the shopping cart. Right? And then does the iShopping cart have a requirement for constructor?
The iShopping cart interface does not have a requirement.
Does it have a method in it?
It has methods, but there is no constructor. So what it takes to actually implement it, it doesn't care. So what do I need the constructor for again?
To actually define the items that are in it. Use your pads. You want that base constructor so you have the base where items list for your properties.
To be initialized.
Right, yeah.
Yes. Yeah. So if I don't have a constructor,
It won't.
order items is null.
Right, you have to actually define them
Right.
and call them.
Right. This is defining it. This is initializing it. So if you go back to C programming, way back, I'm sure none of you took it. But you declare a variable, you actually pass things by reference with pointers. The pointer points to a memory address. So until you actually say this variable equals a new list, the variable itself points to nothing. It doesn't point to a memory address anywhere. It's null. Calling new list order item actually creates something in memory and then puts that memory address inside of order items. So actually end up with something here. So if later on we try to return it or we try to get the sum of it or whatever it is we try to do, if we don't actually have something there, we can't do any of those computations because nothing exists. What?
You get all kind of null pointer exceptions.
Yeah, you will. You get null reference exceptions, what they call it now, yeah. Huh?
Java versus .NET.
Yeah.
Yeah, I'm used to thinking in Java where you can just initialize it right there at top, in the same line where you declare it.
Yeah. And technically you can. You could do it right here just the same. The difference is, well, really there is no difference. They both function the same. But all you can do here is an initialization. So if you had to do any sort of like complex logic or setup, like you had to do something to get it set up, it's not simply an initialization, a straight initialize, you don't have that capability in line. Where if you create a constructor, it's a function at that point. So if you want to declare a variable and set it to something and do a calculation and blah, 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 and then finally initialize a property, you can do that within the constructor.
You pass it multiple lists.
Pass it multiple. So if I had like 5 lists here, like that, yeah. Nothing's coming into the constructor. The constructor's still an empty constructor. Nothing's coming in from the outside. But I can do all of this work. So if I want to do something fancy and say initialize list order items, and then I said, okay, from that, let's say that I had, just for giggles, then you would say items, and then you could go in here and say items dot select I dot products dot to list. So to initialize that second one, I actually had to do a calculation, or a series of calculations actually. So I guess my mind always goes to this scenario, and then doing something like this is just so simplistic in comparison. If I were to have gone and done this, ignore this. So let's say that was my code. you would initialize order items to equal a new list. You would create that list basically. And then when you actually step into here, you've now wasted memory by initializing this to be an empty list because you actually ended up passing a list in to replace it. So instead, if you just declare them, leave them null, and then handle them inside of the constructor, you omit the potential of declaring things twice, or initializing things twice with two different memory addresses. Does that make sense?
If we're not doing anything in the constructor besides just
Initializing, you can do it inline. Then the inline is fine. If you end up doing a more complex constructor, then you run the risk of using twice as much memory. You initialized it, and then you ended up taking the value passed in and using it. So, yeah. So you're okay. You're fine doing it either way. If you have a one-off scenario where you do it, it's probably not the end of the world, obviously. But if you have a class that ends up, spinning up multiple times, I mean, this is the shopping cart. So either you're going to call the null constructor or the null parameter constructor, at which point you'll be adding items to the cart, or if you're restoring a cart from memory, maybe you're pulling in a list of order items out of the database and then you're putting them back in the cart. You're restoring an order that was maybe in process. Depending on which one happens more often, you could end up with not a memory leak, but consuming more memory. So those are operational things you just have to take into consideration. And that's the way I like to do it. Okay. Alright, so we now have a memory shopping cart, and that's our shopping cart that'll just utilize memory. Maybe we implement a different shopping cart scenario that connects to the database directly, so as people are adding items to the cart, we end up giving them some sort of arbitrary user ID, we store their cart order, blah, blah, blah. This one just writes it directly to memory. Shopping cart, that's our interface, we implemented that, products are products, and now we're back to the cart control. Okay, so let's delete those. Public view results list, because that's our default view, our default action. And I'm just going to return view for now. I don't believe it created any views for us yet. No. Okay. So we will do add view. Oh, I'm getting ahead of myself. So from the controller, we need to do a constructor. We need iShopping cart. Shopping cart underscore cart equals cart. Load shopping cart instance. So from here we could actually just pass in the entire cart. Pass in the iShopping cart, master page, add. Alright, so now we have a list. This list will be a table. Table row, table header. Why didn't it not give me the table header? T-head, T-R-T-D. So we can do HTML display for C dot I'm not going to do all that for now. So we'll do a table, table, and then we'll do a for each. Order item I in model dot order items. TR, TD, I dot product dot name, I dot product dot price, TD I dot quantity, TD I dot item total. So this will be product, price, quantity, item total. Two strings, C. Alright, so we don't have anything in the cart as of right now, but that would list out everything that's in the cart. Then we could do table, and now let's do this, T foot, TR, TD, column span, we have 1, 2, 3, 4, style, text align right, then we can say model dot subtotal, to string C, subtotal, tax rate, model dot tax rate dot to string P, total, model dot total price dot to string C. Keep doing that. Okay. Now we need to kind of wire all this up to get it functional. So let's go into our global, and we have our inject controller factory, so let's jump into that. So I'm going to add, I'm actually going to go ahead and use mock again. So let's move this up. So we'll do mock I shopping cart, mock cart equals new that, so mock cart dot setup m dot, or m, we'll do C this time, C dot order items returns a new list of order item, and inside of this we're going to do a new order item. Oh, that's going to get fun. Gonna roll this back. Okay, come on. Where's the freaking comments?
Right.
To the right? Oh.
Right on the right.
EU. I thought it was Control E. Oh. I was tempted to go on a complaint fest for a minute. See, I changed all my casing.
Doesn't make no sense, though. Like, you would think that if you comment and uncomment is the same thing.
Right.
So that would be
Well, and the part that always kills me too is the fact that if you download the newest version of SQL Management Studio, it uses the same like Visual Studio engine. So they've got all like the keyboard shortcuts and stuff. But the keyboard shortcuts in that for comments are different than what's in here. And you gotta do like KC and KU instead of the CE and CU, and that's what I kept trying to do, and then it was just totally getting confused. So that's my soapbox. Alright, I'm gonna do this because this will be more fun. So this will be a list of order items. OI equals mock.products. No. Mock.object dot products dot select new order item, select P products equals P, quantity equals 1. Dot to list. Anybody catch what I did there? Huh?
What's that line mean?
Yeah, what's this line? What does these 3 lines mean?
Reading.
You look at that, I'm going to finish this down here.
We'll take those products up there
Yeah?
and count them
And do what with them?
and add them as quantity. Add them to the order item.
Alright, I got 2 different people giving me answers. What? Eli, you were talking first. Go.
Okay, you will take those products
Yeah?
there and make an order out of them, basically.
Correct. Anybody got more details than that? Alright. So what's the first line do?
You're instantiating a cart with your line, the mock data based off what you have above.
Alright. So I'm making a mock object of iShopping cart.
Yeah.
Okay. And then what are these 3 lines attempting to do?
And then you're building your list of order items based off of, you're making new order items, selecting the items from that mock, that data there,
Mhm.
and you're basically at your pass curve. Setting the list of order items equal to that where the product equals above all the product up there as well as the quantity equals 1 in the end of the list.
Right.
Does that explain that one?
Yeah, so let me repeat back what you said and see if it's a little...
Probably more technical.
Yeah, well, it's going to be a little more direct. So what I'm doing here, so mock.objects.products, this product refers to this array of products above. Plain and simple. That's what the mock is doing. The select call is saying, do a select on each product individually in the products collection. When it selects or pulls one of those products from the collection, what it's going to do is it's going to create a new order item, making that order item's product property equal P, the currently selected product, and then sets the quantity to 1. What select does is it's then going to return iQueryable, or a collection of order items based on looping through each one of these products one by one. So to wrap your head around it again, what the basic idea is it's going to do a for each loop, one product at a time. The select method is going to do that. Inside of the select method, it's going to create a new list of order items inside of itself, temporarily. Then it's going to take this new order item that's created right here, and it's going to put it inside of that collection. Once it's for each looped over every product, it's then going to return back that new list of order items. So what select returns is iQueryable order item. Do you want to see the equivalent of it if I wasn't using the select statement?
Yes, please.
Okay. So I did this work here. So what I'm going to do is do new list. Okay? So I have a new list. I'm then going to do for each product P in mock.object.products. Alright? Then what I'm going to do is I'm going to say oi.add. I'll put this on a new line. New order item, product P, quantity 1. Okay. The difference is that the select, when you call select, select does not return you a list. It returns this other enumerable type called iQueryable. It's a link type. So in order to get from that iQueryable type back to a list so that I can actually store it inside of OI, I have to call toList on this result. So maybe if I break it this way, just so you can see it a little even more clearly. So if I say iQueryable order item, OI query, okay, I would then say OI query equals this. But if I actually want to store it inside of OI, I'd have to say OI query dot toList. Okay. C-E-C-U. Oh, it worked. Nope, it didn't work. Okay.
Is there a performance benefit to writing it one way versus the other?
There is.
Okay.
There's actually a performance benefit writing it the other way. Writing it with the for each loop or a for loop. It's actually faster. In small quantities, it's not noticeable. If it's in large quantities, it's noticeable to use a for loop because it's optimized versus doing it using the link statements. So since this is mock data, it's faster to write it using the link statements. And once you understand link, the link statements are more compact, quicker to write, easier to read in comparison than writing out a whole for each statement and all of these additional declarations and everything. So the link factor is readability and flexibility more so than performance. So you got to kind of weigh the two options. The link benefit also exists when you're using the entity framework. So when you're using the entity framework, it is designed to use link specifically. So there is no real optimization or performance gain the other way, because the entity framework will use these link statements like select or where, and it will actually convert, it uses those as kind of like keyword calls, and it converts them into an actual SQL statement. So you're kind of using this, you're kind of in this not catch-22 scenario, but there's certain spaces where you have to use link. It's designed. That's why link was created, was for this entity framework link to SQL. It was designed for that, but then they realized that there's readability gains and consistency gains if they can actually make it work with any kind of collection. Okay? So the for loops are the fastest. They're the most direct. It's simply a walk one memory space at a time. And inside of these link calls, select, to list, where, they're using for loops, and they're doing all that work at some point, but there's also a lot of other black box stuff that's going on that you just don't know about. There are articles out there that actually show you the performance differences. They go through 100,000 rows of something, or 100,000 items of something, and you can see where the performance gains are using straight for loops. Memory performance is also better because you're putting less in the stack with a for loop than you are with these. I had an application that I wrote that would consume up to 1 gigabyte of memory. It was doing a lot of caching where it would load data in from this database just for performance, and I was using a lot of lists, and I was using a lot of link statements. I went back and converted everything to arrays and converted it to for loops, and the application will now at startup run at 200 meg with a modest amount of load, and then at high load it never peaks past 500 meg. So considering the amount of data that it's holding and carrying, it's carrying basically an entire school district's worth of students, courses, and everything else, that's pretty good. And that it stays there, where with the 1 gig was kind of like the first 50 users, it was boom, 1 gig, and then after that it was just exponential, it just kept climbing until the server either ran out of space or you just had garbage collection happening constantly. So there's also other inherent benefits and drawbacks depending on your approach. So, yeah. But if you've got the understanding of what's happening, just waiting for my line copy to complete. But if you understand what's happening, I mean, it's definitely much easier to write and read those 3 lines in comparison. All right. So we should be able to do /cart, and that should give us a dump. Link text. Copy, null, empty. Oh. So our mock objects don't actually have a category. Sports. So since our mock objects don't have categories, our categories action is looking at those to build the list. It's saying we don't have any text for that link. So F6. Enter. There we go. So there's our football, price $195, one of them is $5.95, surfboard, blah, blah, blah. Subtotal did not calculate. Tax rate we didn't set, so it is going to be 0 by default. And the total is... Huh?
Total would be 0, tax rate.
Yeah, but our subtotal is also 0, so... Alright, so how do we make some adjustments or accommodations for that? So let's kind of think through this. So we can set up, so mock cart dot setup cc.tax rate returns 0. Are we still at 6.5% in this area? Best overload match returns a decimal. But inside of our cart we have an issue. So memory shopping cart. So tax rate is fine. Subtotal should take all the items. I bet the item total isn't calculating. Product price times quantity. Return the quantity. Let's do breakpoint, insert breakpoint. F5. Cart. So there's our 6.5%. Oh. So since we used the mock object for our shopping cart, it's not going to do any of this work because we're not using the memory shopping cart. So that's the problem. So what we actually probably need to do is drop all of this. And we will just bind this to our memory shopping cart. No, that's not what I wanted. F6, okay. And inside of here, we'll say cart.orderItems equals product repository PR equals, I don't have the kernel here, crap. Product repository PR repository PR equals PR. This is pr.products.select p equals new order item. Product equals p, comma, quantity equals 1 to list. I cannot set this because it's IEnumerable. So what I'm trying to do is I'm trying to take that list and I'm trying to put it inside of order items, but order items is IEnumerable and it's a get only. So to work around that, what I'm going to do is, I can't do that. This is where dependency injection can be a pain in the butt.
I didn't understand why it didn't work with mock. It was supposed to.
So the reason it didn't work with mock is that I'd have to set up one of these returns. So we'd have to set up C dot subtotal price returns, and then we need a function that will do the work. So the function returns a decimal. So the function would have to be something like,
And that loops through and sums up all the
right,
prices, that price of each product.
exactly.
Aren't you calculating the price in the shopping cart? Why didn't you take that? Aren't you are binding that shopping cart to your mock? So why it didn't take the total, the calculation of the total?
Because the mock object doesn't know how to do that. The mock object is looking for a way to do it. So your mock object is trying to do its own implementation of iShopping cart. That's basically what it's trying to accomplish. And in doing that, we have to provide all the necessary implementations here inside of the mock object so that it performs all the necessary functions. If we don't define them explicitly, then what ends up happening is nothing, basically.
Basically, it's just using interface functions but not using it, right?
Say that again?
It's implementing the methods of the interface.
Right.
You have to define.
Right. It's just implementing them with nothing.
Yeah, with nothing.
So unless we tell it to do something, it's going to say, okay, well, this interface subtotal price has to return a decimal. It understands that. So all it's going to do is it's going to say, I'm going to create a default decimal value, 0, and I'll return it. That's all it's going to do for us. So unless we give it something more specific, more explicit to do, that's all it's ever going to do. So what I'm wondering is, so this is getting out of my available knowledge. Is if we say M, which is the mock object, it doesn't know what M is. So it wants us to give it a function that returns a value, but we don't know what that value is without. Okay, let's fake it. OI dot sum. So that'll work for us, but then when we do mock cart dot setup C dot total price, returns. I have no idea what to give it. Mock cart dot object dot subtotal. That's what I'm thinking, but I don't know if that's gonna work. One plus. Oh, let's try it. Let's wing it. Why not? Worst case, it blows up, right? All right, so we don't need that. We don't need that. Technically, we don't need that. So F6. That's what I'm waiting for. Even better. Nothing. All right, hold on. I think that's our binding. Yeah. Bind shopping cart to constant mock cart dot object. F6. F5. That is some crazy. It worked. I definitely did not expect it to work, but that's good. I would imagine that if we try to add another item to the cart, it would not change the total. So if we went into the cart controller and we said cart.add new product, name equals golf ball, price equals, I don't know, $2.99. That'll be that. Category golf. So that's what it is now. F6. New tab. Paste. Didn't even show. But I would think that by calling, oh, add doesn't work yet. Cart.setup c dot add returns. So then this is a P. Ooh. What's it yelling at here? So set up property, set up get. Do it. Not to OI. We want to do c.add. Yeah, I mean the end goal is to add it to OI. But it's not, we need a different thing than setup because setup isn't doing it. Raise, reset call, set up a set, verify when. Adds an interface implementation to the mock, allowing setups to be specified for it. That doesn't make any sense to me.
Because you've got a function that accepts a parameter, you can change the mock cart.
Well, I'm thinking that it's because it's a function just in general. Like everything prior to that, they've all been properties. So the functions must have a different setup. Set return default. Okay, so this is going beyond my knowledge of mock. So instead of me sitting here reading the documentation and trying to fake it. We got pretty far though, something at least semi-functional without actually having to do any productive work. Like adding stuff to the cart. So that's kind of the direction that we're going to take with this, though. So then it's a matter of adding actions to actually add items to that cart object. We've got the cart there, and then going through that work. And then adding the update quantity and delete. So quantity will probably end up being a text box instead of just a label or text string in the page. And then we'll have an update link somewhere on there, and then deletes. So that'll be the process that we'll go through. I want to try something just because I made the change to make it work, and I'm wondering if it does. F6. F5. So what I did is I now switched from using, hey, it worked, cool. So this binding was using the mock binding. I turned it off. Oh, come on. And instead I'm actually using the Entity Framework repository. But then I said down here, I said grab the repo from Ninject. So I'm using whichever repo I want to create the mock cart. So that's kind of fun. So now it created one item in the order for every product in the database, is what the end result of that was. So.
And that's every single one, right?
Yeah, it should be. Basketball, baseball, kayak, speedo. Yeah, flippers. Hockey stick. I remember the hockey stick. Cleats. Nobody can spell cleats. So. All right, so we'll pick this up next week. We'll keep moving through it. One of the things that we'll end up doing as well is we're going to start to build some CRUD screens. So CRUD is create, read, update, delete. There's actually built-in functionality within MVC to kind of help us through that. So that'll be a nice thing, and that's when we'll also get to the mechanics will kind of come to play about how do you take form fields and pass them in as an object, and do that from the view of the controller, and doing more complex object types and data types and facilitating all of that. So.